Welcome to this short tutorial video. My name is Mr. Smoma. So we are going to cover significant figures in this video. So we're going to look at significant figures. Are those figures in a measurement that are known with certainty, plus the first two values after the decimal point that are not known for certain in that measurement. So I'm going to write the simple definition so that you can relate as well. Okay, there we go. So we're going to look at it together in case you have difficulties in looking at my handwriting. So significant figures are digits in a measurement that indicate how precise that measurement is. So that is what we have written for you on the board. Now, you need to understand that when we look at significant figures in a measurement, we need to follow certain rules in order to understand how significant figures in a measurement work. So, going to look at important rules that will enable us to understand how significant figures are dealt with. So the first rule says that all non-zero figures in a measurement are significant. They are important. So we're going to write that down. Okay, all non-zero figures are significant. Well, what does that mean? Well, you might have a value in it. For instance, the value that we're going to write down on our board, it says 182,395. So in these values, you can relate with me that in the first value you have 1, 8, and 2. So if this is a measurement, then all the digits in this value are important. So you have 1, 2, 3 numbers or digits in this value. All these values are important. Even down here, all these values are non-zero figures, meaning they do not have a zero in between them, or there is no zero as a figure in the measurement. Therefore, there is 1, 2, 3 significant figures in the values. So that's what the first rule says. All the values in that measurement should be numbers. If there is a zero in that number, then it's not important. So that's what the first rule states. And the second rule states that all zeros in between non-zero figures are significant. So we're going to write it down for you so that you can relate. All zeros between non-zero figures are significant. Okay, so second rule says all zeros in between non-zero figures are significant. Well, what example can we give in there? We have a value that will state the examples like, and our next value is 702. So if you look at these two measurements, first measurement says 304.5, and in this number, or rather measurement, we have a zero that is between the 3 and the 4. So according to this rule, it says that if there is a zero that is between non-zero figures, then that zero becomes important. So in this value, this zero is important, and since the 3, the 4, and the 5 are non-zero values, according to rule number 1, those values also becomes significant. Therefore, we have 1, 2, 3, 4 significant figures in that value. So in our next example, we have 702. So the 0 is in between the 7 and the 2, meaning that it's also important because it's in between according to this rule. So in this value, the 0 is important and the 7 and the 2 then becomes important because of rule A. So in summarizing this rule, it says if there is a value in between non-zero figures, then that 0 becomes important. Now we move on to our third rule, and this rule states that leading zeros are never significant. Leading zeros are never significant. What does that mean? I'm going to write it down for you. Okay, leading zeros are never significant. Well, let's look at our example and see what we mean by saying leading zeros are not significant. Well, we have 0.003045. Okay, so now we have that A and B as our examples. Now what do we have in this example? We have 3 zeros that are leading in this measurement. We have this 0 here, there's that 0 and that 0. They are leading zeros in that measurement. So because of this rule, it states that those zeros are not significant. Therefore, this 0 is not and that 0 is not significant. 3 zeros. But now we can say something about this 0. That 0 is significant because of rule B that says if the 0 happens to be between values, therefore this 0 is significant. Therefore, we can also conclude that in that value we have 4 significant figures. The 3, the 4 and the 5 become significant because of rule number 1. So the 4, the 3 and the 5 become significant because of rule number 1. But the 0 between the 3 and the 4 is also important because of rule. Okay, now we are going to look at C. So what does C say among the rules? It says that leading zeros in a measurement are never significant. So we are going to write down that for you and say, okay, so leading zeros in a measurement are never significant. So what examples can we give in this format? We have our first example that says 0.00356602, and the other one we can give 0.0205. Okay, so if we have our 2 examples there, the first one says 0.00356602. So in this measurement we have 3 zeros that are leading in this measurement or in that number. So in this value we have the 0, the first 3 zeros that are leading in that number. So because they are leading, they are not important, they are not significant. So we are going to put an X to show that those 3 zeros are never significant. But we can say something about this 0 that happens to be this between the 6 and the 2. That one, because of rule C, or rather rule B, because of that, then the 0 between the 6 and the 2 is important. So because it is appearing between the 6 and the 2 that are important. Therefore, we can conclude that in that number we have 3, 5, 6, 0 and the 2 that are significant. So we have 1, 2, 3, 4, 5 significant figures in that number. Now if you look at this example, it says 0.0205. In that number we have 2 values which are zeros and they are leading in that number. Therefore, because of rule C, then those 2 values, or rather 2 zeros, are not important. But we have 2, the 0 and the 5 that are important because of rule A and B. So that is how we can conclude on this rule. It says if there are zeros that are leading in a measurement, they are not important. We move on to the last rule, which is D. Rule D will tell us that if there are numbers that are trailing, then those numbers are sometimes important or significant. This one we need to pay very much attention because we need to differentiate what it means when we say sometimes in that measurement. So we are going to write it down and say trailing zeros are sometimes significant. Okay, so we underline the word sometimes there. So what do we mean when we say sometimes important? Well, we have examples. Okay, so there we go. We have two examples. The first one is 70.000, like that, and then the other one is 70,000. So now, what do we mean when we say trailing zeros are sometimes important and sometimes not important? Well, we have this number here. In this number here, we have a decimal point. Okay, but in this value here, there is no decimal point. So we have a comma instead. So then we can also conclude, and very important to note, that if you have a number, there's a decimal point, then the number of significant in that decimal point will matter. And if there is no decimal point, then the number of significant will also matter. If there is a number with a decimal point, then the trailing zeros. We'll start with our first one here, which says if the number has a decimal point, then all the values in that number are important, including the zeros that are trailing. So in this case, we have 1, 2, 3, 4 zeros that are trailing in that number. Therefore, they become important because of the decimal point. Therefore, this number, this 0, and that 0 are important. They are significant. And because of rule A, then the 7 becomes important because it's a non-zero number. Therefore, in this measurement, or number rather, there is 1, 2, 3, 4, 5 significant figures. But what about the one that is down there? The down example, the second example says 70,000. In this value, there is no decimal point. So because there's no decimal point, there is a comma instead, then the trailing zeros are not significant. They are not significant. But the 7 is significant because of rule A. So we can conclude then to say that in this number we only have one significant figure, which is the 7. So we go back to the rule and it says trailing zeros are sometimes significant. Sometimes is determined by if in that value there's a decimal point, then the zeros that are trailing become significant. But if in that number there is no decimal point, then the sometimes is interpreted as the zeros that are trailing not to be significant. Instead, we only have the 7 that is significant because of rule A. So now we can conclude and say significant figures are those digits in a measurement or in a number that explains how precise the measurement is. In other words, the values in that measurement that are important, that are known for certain, plus the values that are not known for certain. And when you're dealing with significant figures, these are the 4 important rules that we discuss in terms of dealing with significant figures. Hopefully, you now understand how significant figures work and how we find the number of significant figures in a measurement.